So hello, good day. So today we want to look at trigonometric equation involving the sine theta. The last time we dealt with that of the cos theta and that of the tan theta. So today we are looking at that of the sine theta. Okay. So when we have something like this, y is equals to sine theta equals to a. Okay. If we want to look for sine theta here, what are we going to do? We say sine theta is equals to a, and theta from here will be arc sine of A, right? We'll get theta from there, okay? And we also know that from this equation, we know that y is equals to sine theta and y is equals to A, okay? You see this value here is just one of the solutions of this equation. There are other solutions that we also need to determine. And how we get that, we need to draw the graph of this particular equation. The two curves involved are y is equals to sine theta, and the other one is y is equals to a. So where the two curve intersect is the solution to that equation. So let's draw the equation of that of sine theta, and the graph of that of sine theta first. Okay, let's say we have this. We know sine theta starts from the origin, right? Its own curve starts from the origin. So we start from the origin. We'll go like this. Go. Okay. And it continues on the negative side. Like that. Okay. Something like this. Okay. Now, this is y equals to sine. Let's call it x on this side. Okay. Okay, now we have this. We just need to drop a perpendicular just to specify the different range. Now from here to here is 90 degree. From here it's 180 degree. This is 270. This is 360, right? And this one is 450. You just add 90 continuously. 450. Then this one is gonna be 540, and this will be 630. 630 plus 90, so that will be 720, and it continues like that. Okay, so 720, this is 810, then plus 90, that will be 900. So it continues like that. Now you see this particular value theta, this particular value here, it can be drawn on this curve. It's usually between 0 and 90, right? It's usually an acute angle. And when we draw it here, it's gonna be y is equals to a, which is this one, right? So if we draw the horizontal line of this curve, it's a straight line that passes through the curve, right? Now this curve now, where this line intersects this curve, that is where the solution is. These are the solutions, and it continues like that up to infinity, right? These are where the solutions is. Okay, now this value here is the theta. This theta we are seeing here is the arc sine of sine A. Yeah, that's how we get the theta here. And one short thing about this about sine theta is that where it causes this, they're usually symmetrical. From here to here is theta, then from here to here will also be theta, right? That is from here to here, this distance from here to here is theta, from here to here is also theta, right? The same way it is going to be here. Here theta, here theta. So from here to here, from here to here. So this space from here to here is usually theta. So that theta now, if you want to now determine what this point is, so it's going to be 180 minus theta. So this is going to be 180. This one is going to be 180 minus theta. Right? Now, this is 360 plus theta. To get this point, now it's going to be 360. 360 is what? 2 times 180. Let's call it 2 times 180. 2 times 180 plus theta. Right? This is 540 minus theta. So it's going to be 3 times 180 is 540 minus theta. Right? Okay. Now here, this is what? This is 720, which is 4 times 180. 4 times 180 plus theta. Right? 4 times 180 plus theta. While this one is what? 900. So we call this one 5 times 180 minus theta. So what do we observe from here? What we have seen from here is that the theta sign is alternating, right? It is minus here, then it became plus. It started with this one, which is theta. Theta here, when n is 0, then we have when n is 1, when 1 it is 180 now. When n is 2, n is 3, n is 4, n is 5. 180 is common there, right? Then we have seen that theta minus theta plus theta minus theta plus theta. So we have seen that pattern. So the general expression for this is now going to be it's now going to be n 180 degree. That is the numbers. This number 1, 2, 3, 4, 5 is n, then times 180 degree. Now plus. Now you see this minus plus minus plus. How do we represent it? We see that for the first situation, there is no this is when n is equals to 0. And when n is 1, you have this, which is minus. On the odd alternate, we are having minus. So it's going to be minus 1 raised to power n. Then times theta. So which means when n is 0, this will be 0 and everything will be 1. And at that point, this will also be 0. We only have theta, which represents this. When n is 1, that's n time, that's 1. This will be 180. And of course, this is going to be minus 1 theta. That is 180 minus theta. You can see it's representing it. For this one, it's going to be what? When n is 2, 2 times 180, right? Which is what we have there. Then this is going to be plus theta. So it's representing what is here. So this is how we get the general expression for the sine curve, for the solution of the sine theta is equals to